Hey everyone! Today we're going to demystify artificial intelligence. We're breaking down 20 of the most important concepts, but we're doing it simply with no jargon. By the end of this, you'll get how it all works. Let's dive in.
So, let's just start with the biggest question of all. How does an AI actually think? I mean, it can feel like pure magic, right? But underneath all that, it's really just a series of logical, totally understandable steps. We're going to peel back the curtain and see exactly how it works, piece by piece. And I promise, we're going to do this without all the heavy, confusing jargon. The whole idea here is to build up our understanding from the ground floor, using simple, intuitive building blocks. You'll see how each piece connects to the next. Okay, first up, the AI's building blocks. We're starting at the very bottom. We're going to look at how a machine can possibly go from seeing raw data, like a bunch of pixels or just letters in a word, to understanding what it all actually means.
At the very heart of all this is the neural network. The best way to think about it is like a pipeline. Raw data goes in one end, and with each layer it passes through, it gets a little more refined, a little more understood. The first layer might just see some edges, the next combines them into basic shapes, and the final layers can actually say, hey, that's a cat. It's a step-by-step journey from noise to understanding.
So how does that work for language? Well, the very first step is something called tokenization. An AI can't just read whole words like we do. Instead, it breaks our text down into a fixed alphabet of pieces called tokens. So a word like playing might get split into two tokens, play and ing. This is super clever, because it lets the model handle any word you can imagine using a limited set of reusable parts.
Okay, once we have those tokens, the model needs to understand their meaning, and that's where embeddings come in. Each and every token gets turned into a long list of numbers, a vector, that basically places it on this huge complex map of meaning. On this map, words like king and queen are really close to each other, while words like king and car are super far apart. It's how the AI learns the relationships between ideas.
But meaning totally depends on context, right? I mean, take the word apple. Are we talking about the fruit or the tech company? This is where the attention mechanism comes in, and this was a total game changer. It lets the model look at all the other words in the sentence and decide which ones are most important. So if it sees words like stock and iPhone, it pays more attention to them and knows, we're talking about the company.
All right, let's move up a level. We have the basic pieces now: tokens, embeddings, and attention. So how do we assemble them into one of these powerful, intelligent systems? This is where we actually build the brain.
And this slide shows the whole flow perfectly. This is all powered by an architecture called the transformer. It takes all our building blocks and puts them in order. Your text gets tokenized, it's turned into those embedding vectors, and then it's processed through layer after layer of transformers that use that super powerful attention mechanism. Honestly, this is the blueprint for pretty much every major AI you've heard of.
Now, when you take that transformer architecture and you train it on a truly massive amount of text, like a huge chunk of the internet, you get an LLM, a large language model. And you know what's wild? Its main goal during training is incredibly simple. Just predict the next token. That's it. But by doing that billions and billions of times, it ends up learning grammar, facts, patterns, and even a kind of reasoning.
Now, what's really interesting is that we don't build these huge models from scratch every time. That would be crazy expensive. Instead, we use something called transfer learning. A big company builds a massive foundation model, and then other people can adapt it for their own specific tasks. It's just like the quote says, if you know how to ride a bike, learning to ride a motorcycle is way easier. You're adapting a skill you already have.
Okay, so we've got a trained model. Now what? Well, this section is all about how we actually interact with it. How do we guide its responses and control the conversation so we get the results we actually want? Every model has a short-term memory, and we call that the context window. It's simply the maximum number of tokens it can look at one time. That includes your prompt and its own response. Now, these windows are getting bigger and bigger, but they still have limits. And sometimes in a really long chat, the AI can kind of forget things that were said right in the middle. We can also control the AI's personality with a setting called temperature. Seriously, think of it as a creativity dial. If you turn the temperature way down, near zero, the AI gets really precise and reliable. It sticks to the most likely words. That's great for facts or writing code. But if you crank it up, it gets more creative, more diverse, and a lot more unpredictable, perfect for brainstorming ideas. And this is so important. How you ask the AI a question matters a lot. This whole skill is called prompt engineering, And one of the most powerful tricks is called chain of thought, where you literally just ask the model to think step by step. By forcing it to write out its reasoning, you dramatically improve its accuracy on really complex problems.
So these models are incredibly powerful, but they definitely have their flaws, and they can be really expensive to run. So our next section covers all the clever techniques that are used to make them smarter, faster, and a lot more reliable for you and me.
Let's just address the elephant in the room. Why do AIs sometimes just make things up? Well, there's a name for it, a hallucination. And it happens because the model's main goal isn't to be truthful. Its goal is to be probable. It generates text that sounds plausible based on all the patterns it's learned, even if the facts are just completely wrong.
So what's the solution to hallucinations? Right now, the best one we've got is a technique called RAG, or Retrieval Augmented Generation. It's pretty smart. Instead of just relying on its own flawed memory, the AI first goes and retrieves relevant, factual documents from a trusted source. Then it uses those documents like an open book to build an answer that's actually grounded in real data.
And what is it that makes a chatbot feel genuinely helpful and safe instead of just weird? A lot of that comes from RLHF. After the model is trained, real humans sit down and rank different model responses, teaching the AI which answers are better, more polite, or more helpful. This whole process is what aligns the model with our values, making it a much better tool to work with.
Running these giant models is also incredibly expensive. This table shows a few of the ways we're making them more efficient. Techniques like LoRa make it super cheap and fast to specialize a model for one task. And quantization actually shrinks the model down so much that you can run it on a regular laptop instead of some giant supercomputer. These are the innovations that are making powerful AI accessible to all of us.
Okay, for our final section, we're looking to the future. This is where AI moves beyond just spitting out text and actually starts to see, to create, and even to take actions out in the digital world. Let's see what's coming next.
An AI agent is a system that can actually do things. It uses a language model as its brain to operate in a simple loop. It observes a situation, it decides on what to do next, like search the web or use a calculator, and then it does it. It just keeps repeating that process until its main goal is finished, basically acting like an autonomous problem solver.
And what about all those incredible AI-generated images? They're made by something called diffusion models. The process is kind of fascinating and totally backwards. The model first learns how to completely destroy an image by adding random noise. Then it learns how to do the exact reverse, to start with pure static and carefully remove the noise, step by step, to create a brand new image, all guided by your prompt. It literally creates order out of chaos.
So there you have it, 20 core concepts that are the real foundation of modern AI. From neural networks all the way to diffusion models, each one is a crucial building block. We've seen how they work, how they fit together, and now the only real question left is, what are we all going to build with them next?